Let's take a look at how to define a curve using XYZ data points. This set of XYZ points is interpreted with respect to the coordinate system of the front plane, just as it's shown in the reference triad. When creating this type of curve, there's no need to begin a sketch. Simply use the Insert drop-down menu under Curve, select Curve through XYZ points. You can also activate this and other curve commands using the icons on the Curves toolbar. I don't use curves often enough to have a toolbar available at all times, so I'll be using the Insert Curve drop-down menu during this course. This is the dialog box where the curve is defined using XYZ coordinates. Data points can either be entered manually in this table or imported from an ASCII text file. First, let's enter a few points manually. To activate the first row, double-click one of the cells. The row will be activated, and each cell will have a value of 0. Also, the units used in the current document are shown. I'll enter values and double-click the next row to activate it. Notice as you activate a new row, the values from the previous row are copied. I'll enter a few more points. And in the graphics area, you can see a preview of the curve as I define it. If you need to insert a point, you can highlight a row and click Insert to add a new row before the highlighted row. When you complete the set of points, you can click OK to complete the curve. Or you can save the data for later use. If you save the data, the file created will have the extension SLDCRV. I'll click OK and you can see the completed curve. This curve can be used for several things, such as a path for a sweep or a guide curve for a loft. In the Feature Manager tree, you'll see an entry labeled Curve. You can right-click and edit this curve just like any other feature. Now let's create a curve using a text file instead of manually entering each point. I'll open the curve through XYZ Points dialog box once again and select the Browse option. In the Files of Type field, you will see two options, SLD, CRV, and TXT. The first option allows you to browse for a set of points that have been previously saved. The TXT option allows you to import data from an ASCII text file, with XYZ columns separated by a space or tab. You can create this type of file using Notepad or another generic text editor. But if you use a spreadsheet program like Microsoft Excel, you can quickly generate data points using equations and other spreadsheet features. Here I have an Excel spreadsheet with 3 columns. The second and third columns are defined using equations. Before using this file in Solidworks, I have to save it as a text file. I'll select the Tab Delimited Text File option from the Save as Type field. Notice I didn't specify units in the spreadsheet. When I import this data into SolidWorks, the units from the active document will be used. Let's import the curve and you'll see what I mean. In SolidWorks, now I'll insert a curve through XYZ points and browse for the file I just created. Remember, I saved a text file, so I have to change the Files of Type field to TXT. Once I open the file, notice the points are imported and the units have been set to inches based on the units that I'm using in this document. I'll click OK, and there you see the resulting curve. Sometimes, rather than creating 3D sketches, it's easier to create 2 or more regular sketches and combine them using the Composite Curve command. Here I have 2 sketches, one on the top plane and one on the front plane. Right now, they're 2 separate entities. This can be a problem in certain situations. For example, if I create a sweep, the profile will only follow one sketch. It won't profile from one to the other. By combining them into a single curve, the result is quite different. Let's take a look at how sketches can be merged. Here again I have the 2 separate sketches. From the Insert drop-down menu, I'll select Curve, then Composite. The Composite Curve Property Manager comes up with a single selection window. You can select sketches either from the Graphics window or the Feature Manager. As long as the sketches are touching, forming a continuous curve, they can be combined using this command. With both sketches selected, I'll click OK, and you can see in Feature Manager tree, the 2 sketches have been combined into a single composite curve. Note that the Composite Curve command is not limited to combining sketches. You can also select model edges. In this example, I will combine this sketch with several edges on this model. As you select edges, they're added to the selection window. I'll click OK, and the composite curve is complete. Another type of curve you can create is a curve through reference points. This type of curve is defined by existing points, either sketch points, endpoints of lines, vertexes, almost any type of selectable point. Here I have a 3D sketch. What I want to do is create a smooth curve along the path of the sketch. This can be useful for modeling cables or tubing. Although I'll be using a 3D sketch as a reference in this example, it's important to note that I'm not editing the sketch. Curves are created outside of sketches. In fact, if you're editing a sketch, the curve commands will not be available. From the Insert drop-down menu, I'll select Curve and Curve through reference points. Once the selection window comes up, I'll click the endpoints of these lines, and you can see a preview of the curve. If you wish to close the curve, you can do so by checking the Closed Curve box in the Property Manager. There are two uses for projected curves: to take a 2D sketch and map it onto a surface, and to combine two sketches and do a single 3D curve. First, let's take a look at mapping a sketch onto a surface. Here I have a sketch already created on the front plane and a surface. This is an extruded surface, but it can be any type of surface, including any face of a model. You'll find the Projected Curve command on the Insert, Curve drop-down menu. In the Property Manager, you can select one of the two types of projections. In this case, I'll use Sketch on Face. In the first selection window, I'll select the sketch to project. You can do this from the Feature Manager or the Graphics window. In the next selection window, I'll select the face I want to project onto. This can be one or more faces. An arrow will appear indicating the direction in which the sketch is being projected. To change this direction, you can click the arrow in the Graphics area or use the Reverse Projection checkbox in the Property Manager. To complete the curve, I'll click OK, and you can see the resulting curve on the surface. Next, let's use the same Projected Curve command to combine two sketches. These are regular 2D sketches, one on the top plane and one on the front plane. When using this command, the two sketch planes have to intersect. They can't be parallel to each other. I'll launch the Projected Curve command, and this time select the Sketch onto Sketch option. Once the sketches are selected, you'll see a preview of the projected curve. I'll click OK, and the curve is complete. The final type of curve we'll take a look at is the intersection curve. This is quite different from the other curves we've seen so far. The other curves were listed in the Feature Manager tree as curves, not sketches. The intersection curve is actually a sketch tool. It's used to generate curves within sketches, as you'll see in the following examples. Let's start by creating a curve at the intersection of a plane and a surface. I have a planar surface here, but this could be any type of surface or model face that intersects a plane. The intersection curve is found on the Tools drop-down menu in the Sketch Tools section, or it's found under the Convert Entities drop-down icon. Notice as soon as I selected the command, the Property Manager appears showing only a selection box. From the Feature Manager, I'll select the front plane and the planar surface. When I click OK, the intersection curve is created, and I'm placed into Edit Sketch mode for a 3D sketch that was just created. The only problem with this is that if I want to continue working on this sketch, I'm stuck with a 3D sketch, even if I don't need one. Remember that when working with 3D sketches, you don't have access to sketch tools like circles and arcs. I can avoid the 3D sketch by selecting a plane before launching the intersection curve command. Let me cancel the sketch and start over. First, I'll select the front plane from the Feature Manager tree and click on the intersection curve icon. Now all I have to do is select the planar surface to generate the intersection curve. Once I press OK, a new sketch is started, but it's a regular 2D sketch. Keep in mind, I can create an intersection curve between a plane, the front plane in this example, and any surface or model face that intersects it. In fact, if you needed to, you can create an intersection curve between a plane and an entire part. Just select a plane, launch the intersection curve command, and instead of clicking a face from the graphics area, select the part icon in the Feature Manager tree. In the last examples, I used a plane to create intersection curves. You don't have to use a plane. You can create intersections between two surfaces or faces like these here. Instead of pre-selecting a plane, I'll launch the intersection curve command and then select both surfaces.